Welcome back, guys. So, yesterday we've been trying to pass the directory entry once we have the physical block of a particular inode. We need to pass the contents of the inode as either a directory entry or a file entry, and we were trying to pass the root node's content as directory entry, and we managed to see the entire output. But one thing that we were missing is that the moment we get past the first directory within the root node, we were not able to continue passing the next bytes as a directory entry for some reason. And when we tried to print the entire thing and checked why we are not able to pass the upcoming entries as directory entry struct, we realized that there's something missing. Some The entire structure has some manual entries between a directory entry, at least something like that. We need to figure out, or we need to read the actual documentation to find out what exactly is there to start with. So that's going to be today's deal. So overall, we're still trying to write our own kernel, and we are working on the VFS layer of our kernel. Almost we have been done with the MMU layers and scheduling and a little bit of stuff around that. And we are working on the VFS layer. Yeah. So let's get into it. So as I mentioned yesterday, we have this loop and it's going to take raw bytes as input, and that's just the content of the inode physical block, and we need to parse this raw bytes as directory entries. So we have a while loop which starts with the offset as 0, and we just keep uh, casting those bytes as directory extend directory node, which is a struct. So it has few fields, and as I explained yesterday, we need to make sure we read the name length and dynamically read the file name. So, but overall, we should still be able to cast it here and then go past the file name field. This is how the actual um, structure should look like, and this is how the actual entry should be passed. But what we are missing is that my assumption was that once we have the directory entries, we can keep casting every bytes. We start from the 0th byte and we cast it as this struct and move past this entire offset and keep recasting the other bytes. That's how I was hoping to do it. But turns out that is not working because, as you can see, I start from the 0th node and I cast that as a directory entry, and I'm able to read the first directory. But the moment I read the second directory, I just get empty values. And yesterday I was trying to debug it by just printing whatever that is there from the starting, and the difference between two directory entries is not linear. I mean, it is not supposed to be linear because we do have a file name field which is dynamic. Still, if we actually know the length and then we calculate the file name, we should be able to calculate the distance between the separation between each directory entries, but it is still not working for some reason. And in the end, when we were debugging this, we managed to get some information saying that we cannot keep on parsing every block as linearly we were expecting to do. So looks like there is something called VX root info, but I'm not going to believe this because I have no idea why all of a sudden this came in. So I'm going to just do some research on how exactly we need to parse extend directory entry. That should help us parse and extend directory entry. So let's see. So looks like this is the general algorithm. So in case this flag is not set, I think that flag is supposed to give some hash tree or something. But if it's not set, looks like this is the algorithm. So we reread the inode number, we read the record length, we read the name length, and we read the file type from the start of the entry. So this is exactly what we do. We read the inodes, record length, name length, and file type. So it's all the same. And once we have the name length, we just advance the offset by record length. That is all. This is what we have already implemented and looks like it's not working. So maybe it's possible that in our case there is a extend index flag set. So we need to still confirm if this flag is set or not in our case. How to confirm if this flag is set. So let's see if we have this flag enabled in our case. Okay, we need to do it manually. So let's try asking it how we can do it manually. Yes, we need to figure it out programmatically so to confirm what's going on. Also, is there any information about this in our next? So we do have it. Maybe it's part of the inode actually, because when we pass an inode, we do have some extra metadata, and we don't read any of those in our case, because in our case we only read the inode I block and some other field. There's only two fields that I'm reading. Probably it's left somewhere else. Node calculates the hash of the desired file name and uses it to find the corresponding block number. Okay, so it's like we need to just get the hash of the file name and look it up in this B-tree, something like that. And I don't want to do that. I just want to do a normal. Okay, it's part of the I flags field. And if the offset 0x20 is set, that means okay, I think we can do that. So file C, when we actually read the inodes, must be somewhere here. No, it's not. That's the inode passing because we need to find the flags at that level. Must be here in this file for sure. Inode num to inode, probably this is the one. So we have read the entire inodes. And we are reading the I block, which is the 0x28 offset. But in our case, we need to read 0x20. Okay, so let's read that. Read that flag as no, I don't have any particular schedule as of now. I'm just streaming whenever I get time. It's not idle, but I don't have exact schedule as of now. I don't have an exact schedule. I need to read the 20th offset, but I need to cast it as some data type. I'm looking to find what is the data type of that fields. I flag. Okay, so I flag is 0x20 and it is should be uint32. Okay, so let's cast it as uint32. I flag. It's going to be data plus 0x20. And we can cast this as uint32 pointer. And then I can just no, I can just dereference it here. So I have a offset which is data plus 20, which is the I flags, and I can just cast it as uint32 pointer, and then I am dereferencing it. So I get the uint32 value. So here I'm supposed to check which index 0x100. So maybe it's just like, yeah, this one. So it should be like I can and uint 32t. What the fuck? Uint 32t out equal to, let's say, I flag and I need to and it with so it should be 1000 and the decimal number is 4096. So I and it with, I think I can just simply put something like this: 1 2 3 4 1 1 2 3. Then it's just 4. So it's this. Am I correct? Let's put 1 2 4. Yes, I am correct. So it's like this. So if I add this with I flag, and if I get what 4096, I think so. Because if I add both the things, only the values that has both 1 will actually stand out. So I know flags. Out. Put. And it's just out. Okay, now we can run it and see what's there. Oh, shit. And it's going to be I know flag. There's just one I know flags and its output is just 0. Okay, maybe let's just print I flag then. Maybe we are not reading it properly. It's possible, but I'm not sure. Okay, so this is what we get. 524288. So it's going to be decimal to hex. So it's going to be 524288. Is it correct? 524288. And the hex number is 8000. If we come back to our list, I think it's 8000, right? No, 80,000. If it's 80,000, so it's just inodes uses extends. So let's see here. This is the flag that is set in my inode. Zero x 100 is not set. I believe so because I'm reading 0x20 as event. So it should be correct. Yeah, that's what we did. And out is definitely not set. Yeah, so the H3 bit is not set. So how do we pass the extents? Directory extents. So we start with offset 0, and we advance as record length. But still it's not working. Okay, so I'm pretty sure now we are doing everything correctly because our output does not have the H tree value set. And our algorithm, our loop also looks just fine. It's just straightforward. We have just a single while loop. We have the currents and we have the raw bytes plus currents. And then we get the name lengths. And then we are printing the record length, which is 12 in this case. And then we move past record length. Okay. There's still nothing. Because after the first directory entry, we just see node. Something is wrong. How is this possible? I have my directory node, and I'm pretty sure that the there is an entry after the first entry because we just printed everything and we can see that the next entries are there. So the only thing that we are missing is the length that we need to move past, or the offset value. So we just have to confirm why we are not able to get past record length and find something that is valuable. So it's going to be correct entry. So we start from 48. What? Why is current still in 48? Maybe this is the issue because inside the loop, I'm just printing it in the top. So in the first attempt, we get the address as 2448. And the second attempt, we still see the same address. But we are incrementing it with current plus equal to record length. What is record length? It's an uint 16 value. Maybe current is uint 64. Still the value is same. How come? Also the value is same. Hi, hi. The address is same, but the value is not same. That's even more crazy. Yeah, in the first iteration, we can see the address is 2448 and the value we got is 12. We did increment it, but it's not showing up here, and the address is same, but the record length is different now. That's just fucking crazy. You just have to print it here and see if it be even current value at the end. Let's see. It's going to be current. Let's run it. For some reason, this is just not working. I'm able to print current record length. If I use it here, it's not working. What the fuck? It's just crazy. Okay, let's do this. U and 64T. You won't get any jobs. What does that even mean? Take no stress. Who said I'm stressed? Who the fuck said I'm stressed? It's going to be current nodes length equal to current node record length, and let's cast it as event 64. And let's print it here. But who the fuck said I'm looking for a job? Current nodes length. And I can just use it here. Condition length. I never thought I would be debugging a increment operation. Maybe something is wrong with my setup. Wait, did I miss anything? Plans. So what's the error? Okay, I'm just just put one here. One. So now, okay, so now the record value, current value at the end is 12, but the directory entry hasn't changed or hasn't moved past the initial thing. Why is that? That's the current. Current job. It's going to be current. And if I say builds, so we start with current value at the top is just 0. And then we have the current value at top, which is 12. Okay, so now the value is incremented. We have 280 and 2. And 248. Okay, so now it's incrementing, at least for the first iteration. But after that, probably my record length is just 0, so there's no difference. Okay, so now I need to understand why my record length is 0. Also, I need to print my entire character byte just once. It's just so fucking annoying. So far, pointers. So it's going to be index and value. And index is HH and value is raw bytes plus HH. And if I try that, what the fuck? Okay. Now if I run it, so this is the zeroth index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the second directory entry would start from this offset. And what we have there, 1, 2, 3, 4, 5, 6, 7, and 8. And the ninth field in that index does have the proper outputs. So why the fuck is it not working? So there's 8 here. So maybe I'll say, let's see if we say raw bytes plus equal to 22. So what if we start from this 22 bits? Still did not help. Something is absolutely wrong in my setup. I just don't know what the fuck is that. But it just looks so fucking simple. It's just like 20 lines. And I have the entire raw bytes. I'm starting at offset 0. I'm casting the first bytes. I'm printing it from the file name. It's offset as the current node length. But I'm using S, that's why it's looking like it's keep on Yes. C4. So you see, nothing is working. That's even more annoying. But whatever, at least yes is working. I just can't seem to wrap my mind around this fucking record lens. How is it not dash? So I have record lens, and record lens is 0. One thing that's that could have gone wrong is that maybe this entry actually does not have proper record length. But if that's the case, then why is there proper strings after every interval? So as you can see, we have a little bit of empty space, which is the initial fields, and we have some characters, and empty fields and characters, empty field and characters. So definitely maybe it's record length plus one. What if there is a empty string or the null byte? Because for some reason this format specifier is able to find the end of the string every time. So maybe there's a null byte. So we start from here, top is 0, and then the record length is 12, and the current value is 13, and the record length is 0. Now the current length is 12, 14, and still the same. 15 is still the same. Then where the fuck is it actually? No matter what we cast it, it's still not working. Let's just try to brute force which offset is working. Let's try -3. It must be starting from somewhere. No, that's not going to help. We need to, yeah, let's write another loop here. Let's just say let's take this line, paste it, and it's going to be hatch hatch. So let's just see which it's going to be current nodes. That's file name. So now we are just brute forcing every index. So from every index, if we try to cast it and see which index actually is providing a proper value. So if we cast from 0th index, we should get a proper value. And if we keep brute forcing every index, let's see if we can get something. So 0th index worked. After that, nothing worked. That's odd. Because for sure those entries has these values. So maybe it's issue with my type. Then how come the first block is getting parsed? If first block is getting parsed, the rest of it is not. Let's remove this. And let's convert this into this. Now if we do the same parsing, let's see what happens. Okay, now we are casting it, so we just get failed. So let's see this. What the fuck are we doing? We're trying to print that as a string. And why is it not working? Okay, let's just say a record length. What about this? So for the first index we got 12. The second index we got the same. And for the 11th index we got 12 again. And everything else is just 11th index. I have no fucking clue. At least I should have got some numbers. Because there's multiple nodes for sure there. Because I can see it here. So there's at least 1, 2, 3, 6, at least 12 nodes. So for sure there's 12 nodes. But nothing seems to be having any actual value here. So we have to do again figure out what's more. Why casting the bytes as extend is not working. Let me check my next implementation of this algorithm. Because it looks like it's not anymore a casting issue. It looks like the entire structure is wrong. So I'm not sure as of now. Okay, what if we remove this file type and cast it? Let's just say um, okay, so far sure something else is wrong. I need to look deep into it maybe tomorrow. But overall, we are still stuck in the same state as yesterday. We have the empty bytes, or we have the full bytes of the directory entry that we have read from the physical block, and we are sure that the raw bytes actually has the values, because if we just print it, everything is there. But when we try to parse it as directory entry, we don't see anything. That's the issue. Yeah, I guess I'll think about it again tomorrow. Have to maybe get some actual implementation from Linux and see how they do it once they have the actual physical block in some buffer. How exactly do they parse it? Because today we also tried one more thing, which is to confirm the flag, and we confirmed that too. It confirmed that we don't touch tree flag set based on I flags fields being 0x800. So we should be able to parse the extent entries linearly. So that should be the question for tomorrow. Yeah. Okay, guys. So tomorrow I'll just continue with this because I'm only planning to stream 1 hour every day, so it will be like 2 or 3 times a week. Okay. Thank you, guys. I'll see you tomorrow.